Solving quadratic equations by completing the square. Let's say we want to find which values of x satisfy the equation x squared plus 6x plus 9 is equal to 10. We notice that we've got a perfect square on one side, so we can factor it, and that would give us x plus 3 quantity squared is equal to 10. At this point, we have a situation that's easy to work with. We need to take the square root of both sides, leaving us with x plus 3 is equal to plus or minus the square root of 10. And by subtracting 3 from each side, we are left with x is equal to negative 3 plus or minus the square root of 10. This works because the equations in the form of x plus b quantity squared equals c are easy to solve. So our goal in this video is to put any quadratic into this form so we can take advantage of this method. Let's see how this might work using x squared plus 4x equals 0 as an example. I know that you can solve this with factoring, but bear with me. Think about what x squared plus 4x looks like using algebra tiles. We can't just arrange it into a square, but you notice we can get fairly close. We can make a square by adding 4x to each side in 16 units, but that would leave us with x's on both sides of the equation. And while that is not wrong, it would prevent us from using this method. So instead, let's distribute the x's evenly on both sides of x squared. Then all we really need is to add 4 units to complete our square. Of course, adding 4 to one side of the equation, we would then need to add 4 to the other side of the equation, or the equation would not have remained equivalent. This gives us x squared plus 4x plus 4 is equal to 4. And then we win, because that's just x plus 2 quantity squared is equal to 4. And when we take the square root of each side, we get that x plus 2 is equal to plus or minus 2. Remember, when we see a plus minus sign, that means we have 2 possible solutions for x. So to solve for x, we need to solve 2 equations. One when x plus 2 is equal to 2, and one when x plus 2 is equal to negative 2. When we simplify those, we get that x could equal to 0, or x could be negative 4. Now, let's do a quick check of that answer. We always go back to the original equation. When we substitute 0 for x, we get 0 is equal to 0, so that checks. And when we substitute negative 4 in for x, again we'll get 0 equals 0, and that checks. So, both 0 and negative 4 are solutions to our original equation. Now let's see how this works in general. Quadratic equations can be written in the form x squared plus bx equals c. Notice that the coefficient in front of x is equal to 1. If you come across a problem where that isn't the case, you can just divide both sides by the coefficient to get the problem in this form. This would give you new values for b and c, but that's okay. Now we're ready to start forming our square. We will use the algebra tiles to help illustrate that this method will work for any quadratic, even if we don't know how to factor it. Now, just like in the last example, we'll be dividing bx in half and putting the other half on the other side of the x squared. This leaves a space for the piece needed to complete the square, which would be 1/2 b times 1/2 b, or 1/2 b quantity squared. And while this looks complicated, it's just a number, since in most problems we'll know what b is. So, to complete the square, we will need to add that number to both sides of the equation. And then we win again. We've gotten the left-hand side of the equation into a perfect square. Therefore, we can now factor it. So now our left-hand side would actually say x plus 1/2 b quantity squared. That was the whole point of doing these manipulations, was to form the square. And now all we have to do is take the square root of both sides. And in doing that, we have a problem that has only one x in the equation. So now we can solve for the 2 values of x. Now let's look at a problem that's a little more complicated. 2 plus x squared minus 12x plus 1 is equal to 0. To get this in our general form of x squared plus bx equals c, we need to divide every term by 2. And that would give us x squared minus 6x plus 1/2 is equal to 0. And then we need to move the 1/2 to the right side of the equation by subtracting it from both sides, giving us x squared minus 6x equals negative 1/2. Now we'll be looking at the b term, which is negative 6. And we'll take 1/2 of that, which gives us negative 3. Now we will square that, giving us 9. So it's 9 that we'll be adding to both sides of the equation. So our problem will look like x squared minus 6x plus 9 is equal to 8.5. Next, we factor the left-hand side, giving us x minus 3 quantity squared is equal to 8.5. Now let's take the square root of both sides of the equation. The square root of x minus 3 squared is x minus 3, and the square root of 8.5 is approximately plus or minus 2.92. Now we need to solve the two separate equations, and we find that our values for x are approximately 5.92 and 0.08. If we needed an exact answer, we'd have to leave the square root sign. So I would go ahead and convert that to a decimal, getting x minus 3 is equal to plus or minus the square root of 8.5. We would then add 3 to both sides of the equation and get that x is equal to 3 plus or minus the square root of 8.5. Let's do a quick review of the steps needed to solve a quadratic equation by completing the square. First, we want to get the equation in the form of x squared plus bx equals c. We then find 1/2 b, quantity squared. We complete the square on the left-hand side by adding 1/2 b, quantity squared, to both sides. Then we factor the left-hand side. We take the square root of both sides of the equation. And we solve for the two values of x. The fun thing about this is it can be used to solve any quadratic equation. And on top of that, it's actually how the quadratic formula is derived.